By now, we have understood that the unsupervised machine learning is a technique where the algorithm tries to find the hidden pattern and trends within the data. Based on the hidden insights, unsupervised learning tries to find out the information, find out the grouping, clustering, or segmentation of the data sets into different groups. Based on that, we have different types of unsupervised learning based on what type of problem we are trying to solve. The first type here we will be discussing about is the clustering technique. Clustering is a key technique in unsupervised learning that aims to group the similar data points into the distinct clusters based on their inherent characteristics. Unlike supervised learning, clustering does not rely on labeled datasets or predefined categories. Instead, it seeks to discover hidden pattern or structures in the data. The main goal of clustering is to ensure that the data points within the same group or same clusters are more like similar to each other than to those who are in the different groups. This method is highly effective in analyzing large data sets where the labels are unavailable or very costly to obtain, making it very powerful tool for exploratory data analysis and even the feature engineering in the case of generating the labels. Now think about many different organizations, many companies, those focus on creating labels. Either the email is spam and not spam. Now, if somebody has to sit down for millions of emails every day and make the labels for spam and not spam, how much costly it's gonna be for different email providers. And that's where the use case of unsupervised learning clustering comes into the picture. There are various clustering algorithms, each suited for different types of data and different type of problems. One of the most popular algorithm of clustering is k-means clustering. We will be talking about different type of clustering techniques here. I'm just taking a name for the examples, but we will dive super in depth into each of those clustering techniques as we go more into the specific topics into our next videos that are in my YouTube channel. The k-means clustering mainly partitions the data into specified number of clusters by minimizing the variance within each groups. Now, another popular algorithm is DB-scan, which is also called density-based spatial clustering of applications with noise, that can easily identify clusters of varying shapes and densities and can handle the noise in the data. Clustering is widely used in many real world applications, such as the market segmentations, where businesses group customers with similar buying behaviors, or in image compression, where it helps to reduce the number of colors or features while maintaining the essential structures of the image. The flexibility and effectiveness of the clustering in revealing insights make it really valuable techniques in unsupervised learning and very valuable machine learning technique in the real world applications. Next, I want to show you is what are the different clustering algorithms, clustering techniques that we can apply in the diverse amount of data and based on what type of problem we are trying to solve, what type of grouping that we want to achieve out of the data. Here are the list of different clustering techniques, including k-means clustering, k-midpoint clustering, agglomerative clustering, divisive clustering, DB-scan clustering, and Gaussian mixture model. These are almost everything on the clustering algorithms. Of course, these individually have their own use case, own type of applications into the real world business problems. We can use each individual type of clustering techniques for our different problems that we are trying to solve, and they achieve their own level of accuracy when it comes to cluster and group and segment the data sets. K-means and k-midpoint both are similar type of clustering algorithms which group the data based on how farther away the characteristics or nature of the data is from each other, and they create the cluster centers and they measure the distance from each individual data points to the cluster centers, and they map the data points to the nearest cluster centroid. K-means works based on the average distance of the data points to the cluster centroid, where K-midvoid clustering works in the median distance from the data points to the cluster center. When it comes to the outlier situation, K-midvoid clustering outperforms K-means clustering, but however, K-means clustering is really powerful as well. Agglomerative clustering works at the hierarchy level. When you have some kind of data which needs to be broken into the hierarchy, then agglomerative clustering and divisive clustering are the techniques to go. DB scan clustering is another powerful one. When you have the data which is not into the linearly separable or divisive, then DB scan is really powerful as well. And of course, I have included individual tutorial on each of these algorithms, each of these techniques, and I have provided the mathematical intuition and very in-depth definition plus the Python code implementation of each of these algorithms, and I have deployed them into the web application in my YouTube channel. Please do not forget to go back and check them. These are really in-depth and very helpful for you to build your knowledge into the unsupervised learning clustering techniques. Now, the immediate next thing that we will be learning about is the dimensionality reduction. In the unsupervised learning, first we learned about clustering. Next is the dimensionality reduction. What exactly is the dimensionality reduction? When you have the large amount of data, not only the number of rows, the rows can be hundreds and thousands and millions and billions of rows. How about number of columns? When you have a large number of columns, your machine learning model has to learn a lot from the data, and it's not necessary that your data, each individual columns are really equally important for the machine learning model to learn from the data. Many of the time we have seen in the real world scenario that the columns do not add any value for the machine learning model to learn from the data and get trained to predict the unseen labels. By saying that, what we want to do is we want to reduce the number of features whenever possible, but we also want to make sure that there is no missing or no losing of a lot of information from the data. If we do that, then we are going to lose a lot of information and the model will not be able to get trained with the necessary information that model will need to learn from. That is the reason we have to take care. The first thing is we reduce the number of features, number of columns that are not very important. Number two, while reducing those number of features, we also want to make sure that we do not lose that information. And that's where the rescue is the dimensionality reduction techniques, and we will talk in depth about those here, some explanation, plus in our next videos I have also included each individual tutorials, in-depth tutorial about individual types of the dimensionality reduction. Please do not forget to check those. One of the most popular technique of the dimensionality reduction is principal component analysis. Principal component analysis, or PCA, helps us to reduce the dimensions by keeping or retaining most of the information from the data. So principal component analysis transforms the data into the lower dimension or projects the data into the lower dimension by calculating the covariance, mapping into the lower dimension, and figuring out what exactly can be the lower number of principal components or major number of features that retain the most of the information from the rest of the data, and also have the least number of features so that our model can quickly train with less number of columns instead of having to train with so many number of columns. That's the idea behind principal component analysis. The next one is T distributed stochastic neighbor embedding, or it's called TSNE. TSNE is another yet powerful technique that helps us to transform the original data into the lower dimensional space, and that helps us to capture the essential pattern and the relationship. Basically, teaching is more about helps us to visualize the higher dimensional data into the lower dimension so that we have the better understanding about the data and we can capture everything that we need to capture, even if the data is on the very, very high dimension. Now, the next topic we want to talk about is what are those different algorithms except the PCA and t-SNE. So here are the list of those dimensionality reduction technique that will help you to get the lower dimensional data from very, very high number of dimensions or very, very high number of columns in your data set. The principal component analysis, of course, we have talked about it, and kernel principal component analysis is one another powerful type of principal component analysis. It helps us to map those dimensions, very high number of dimensions down when you have the complex dimensions, not the typical amount of the columns, typical amount of features, but when we have the higher dimensional spread data and we do not have much of the pattern within the data. Linear discriminant analysis is LDA is another technique, and that also helps us to find out the lower dimensions from many features within our data. t-SNE we already talked about, and factor analysis is another technique that helps us to reduce the dimensions and help our machine learning model to find out best features without having to train with all noisy features within our data set. Now, let's move next towards what exactly are the steps of the machine learning model and what are the steps that we need to follow to complete, to start to finish the machine learning models. Let's understand those one by one. The very first step of the machine learning model development lifecycle comes is the data collection. Data collection is definitely inseparable step of the machine learning model, because without data you cannot train the machine learning models. You need the data to train the machine learning models and help the machine learning models to predict for the unseen labels. That being said, you need the data to train the models to understand the problem and predict for the future. That is why you need to collect the data from all necessary sources in necessary formats. Data can exist in any formats. We have talked about different types of data and sources of the data. So that's one of the most important steps in the machine learning model, and the very first step after we figure out the business problem and we discuss with the business team and build the team, build the strategy to develop the machine learning and data science project. Next comes is the data cleansing. Your data always does not come in good quality. There are a lot of problems in the real world data sets. So you need to understand what is the quality of the data, what exactly the data looks like. Are there any missing value in the data? Are there any outliers and anomalies within the data? What does the distribution of the data look like? Does your features have any relationship with the target variable with the help of hypothesis testing and so on? So these are the steps of data cleansing. Basically, your data has to be clean enough so that your machine learning model smartly understands the data and is able to predict for the future unseen target values. So that's the objective, and if the data is not good quality, is not clean enough, then the machine learning model will not be able to correctly learn from the data and do the right prediction. Sometimes machine learning predictions can be misleading if your data is not of good quality. That is why you may want to very carefully and very intensively clean and prepare your data before you even start the machine learning model process. The next very, very important step is the exploratory data analysis, or EDA. EDA is a very inseparable part of machine learning model. Necessarily, machine learning models do not need the data to have the EDA done, but you need to understand the data before you take that data to the machine learning model for the training purpose. Why that is important? Because if you do not understand the data, you do not understand what type of problem, what type of machine learning model is the best to solve the specific problem. Think about an example. If you go to the hospital for some treatment, doctors ask you so many questions: your symptoms, your any allergies, any medications you are taking, etc. They provide you a form to fill out to provide the information about your past medical history, or if you have any specific symptoms related to COVID and so on. They ask you many of those questions. Why? Because they want to understand about your symptoms so that they can give you the correct treatment. And that is the reason they need to first understand the symptoms, understand the concern before they could help you to get well by providing the necessary treatment. Likewise, data scientists are often called data doctors. So, being a data doctor, you need to understand the problem, you need to understand the data, and then you can deliver the solution accurately. And to understand the data, the exploratory data analysis is only the step. So before you do any machine learning model, after data cleansing, you need to do exploratory data analysis, so that if even if after cleaning the data there is some problem, you can further go ahead and clean the data and make the data usable for the machine learning model. That is why exploratory data analysis is necessary, very important. And some of the steps are statistical analysis, understanding mean, median, mode, max, standard deviation, range about the data. The probability distribution helps us to understand what is the actual distribution of the data, if there is any outliers on the data or not, if there is any anomaly situation or not. Those things, the probability distribution will help us to understand those complex situations, helps us to clean the data more accurately. Data visualization, of course, we need to have the good visual understanding of the data so that you can have good understanding of what type of machine learning models will be more accurate to train and solve the specific problem. The next one is feature engineering. Feature engineering is the very important step in the machine learning model. Feature engineering helps us to create the new features given from the existing data. So think about this. If you have three columns that are really valuable, but you think that you can generate a new column from one of those or two of those three columns, and you are performing some level of aggregation, some level of data transformation, and you are creating new columns. Think about, you have the customer monthly income and customer monthly expenditure columns within your data. Now you want to calculate some more information column to understand if customer is going to spend some amount of money in your grocery chain that you have in your local area. So to do that, you may want to find out the monthly saving that customer does. Now you can perform the aggregation method by subtracting the expenses from income. You will get savings, and by that you will understand if the customer can afford the certain product of your company or not. That's one of the technique of feature engineering, and there can be many different ways that you can perform the feature engineering. I just try to provide simple example. After we have the feature engineering done, we need to also be able to perform the feature selection. Feature selection is the technique where we will be selecting only the important features and eliminate the non-important features manually. And there are automatic techniques as well. However, it is really important for us to select only the most important features for the machine learning model for training purposes. If you have so many features already created using feature engineering or the original features from your dataset, then you have to be able to select the few features that are important for the machine learning model, not all the features that are important to take for the machine learning model. That is why there are some techniques you can utilize to select only the most important features and eliminate what is not important. For example, decision tree random forest provide the feature importance calculation by which you can filter in all important features and filter out what is not important features. In even logistic regression coefficients, linear regression coefficients will provide you the idea behind what feature was important, what feature was not important. According to that, you can select or eliminate the features and take it forward for your machine learning models. After we have pre-processed data, the next step is to train our machine learning model. Now, training is a really important part of the machine learning and data science project. Model training consists of training one to many machine learning models based on what type and size of the data you have and what type of problem you are trying to solve. Always, it is not necessary that your only one single model will provide the best accuracy or best results. So you may want to try training multiple machine learning models together and have a comparative analysis. What type of machine learning model, what machine learning model has done a great job, and what machine learning model has not done a great job. So something that you may want to check on that, and select the powerful and the best machine learning model out of all the models that you have trained on your data. So machine learning model training comes after data is ready, pre-processed, cleaned. So that is what you may need to take care about. After you have trained machine learning models, you may want to evaluate the performance of the machine learning model. Model evaluation comes in the way that you have trained a model and you will check the accuracy of your machine learning model on your training data that has the training features and the labels as well. Then later, what you will do is you will test the accuracy of your machine learning model into the unseen data, which does not have the target variable but has the training features. And you will have a validation set, which will also help you to validate the accuracy of the machine learning model. Now, you will also check the underfit and overfit. That is also called bias and variance. Bias is the situation when your data has not learned enough from your training data, and overfit or variance situation is when your data has learned a lot from your training data but is not able to generalize enough on your test data. Accuracy on the test data is very low comparing to the accuracy on the training data. That is situation of the variance, and you may want to appropriately treat those bias and variance situation. And I have also included the video on bias variance trade-off and how to resolve these kind of issues when we have in our data set. So please do not forget to check those. And model evaluation is one of the most important technique after our model is well trained and is able to predict the values as we have expected. Or if it is not up to the expectation, then you may want to perform the next step, is that is hyperparameter tuning and cross validation. So hyperparameter tuning and cross validation are the steps when we try to improve the model's performance on accuracy and also reduce the bias and variance situations. So hyperparameter tuning is something that we say when our model is about to be trained, we set some parameter value. So modifiable parameter values are called hyperparameter. So hyperparameter, you need to do is we need to tune those values in such a way that our model's accuracy improves over time and over the iteration of the training. Cross validation is breaking the data into the multiple subsamples and retrain the machine learning models onto those subsamples and try to get better accuracy. So this is the way that how we improve the model's accuracy, model's performance in our training and test data set. Once we have completed hyperparameter tuning and cross validation, we want to select the final, the best model that has highest accuracy on training and test data, plus has the lowest overfit and underfit problem. So we don't want our model to have high bias. That means model's accuracy on the training and both test data is not great, plus high variance where our training accuracy is extremely high, but test accuracy is not that great comparing to the training accuracy. So we want our model to have low bias. That being said, our model has good accuracy and low variance, where our model has the same accuracy on the training data comparing to test data. So in that situation, we will pick the model that has the highest performance on accuracy, having low bias and low variance as well. So that's the model selection we would do, and that's one of the most important step in our machine learning life cycle. The next is once we select the best model, we may want to deploy the machine learning model into production so that our end users, our business customers, can utilize the machine learning model and do the complex business decision with the help of your model that you have trained. That is called data driven business decisions, and that's where our model comes into the production and helps the business to run efficiently, accurately, with the best possible decisions that is driven by the data, driven by the machine learning models. Once your machine learning model is deployed into the production, you may want to consistently monitor the performance of the machine learning model, since there might be any issues, any errors that in the system which may cause failure of the machine learning model to successfully spit out the predictions on the data set. So you may want to consistently monitor the results and see if the machine learning model is still performing up to the mark. Plus, the current data that you want to get prediction may be different than when you have trained and tested the machine learning model. And that is the reason one of the most important step of the data science and machine learning lifecycle is retraining of the machine learning model. The reason behind it is because, say you have trained your machine learning models 6 months ago and you have deployed into the production. After 6 months, many business scenario, many business situation changes. Internal and external environment changes, and the data also changes. So your machine learning model was trained on the data that was available 6 months ago, but now the current data is no more valid, no more relevant to the current situation. And that is the reason you may want to take the machine learning model out of the production, retrain it, and make it relevant to the current situation, and then push it back to the production. That's the very important step of the machine learning and data science project lifecycle. You may want to consistently perform model monitoring and also retrain the machine learning model based on the changes in the situation, business process, and internal and external environment within the organization or around the organization.
Many congratulations! You have finally completed the very first step towards entering into the world of data science and machine learning. Understanding data science foundations, machine learning basics is not easy. Entering into completely new field is the most difficult thing. From learning the new topic to learning a new language, learning new skills, including driving, swimming, or whatever new thing that you are going to learn, it never goes easy. It's always difficult, always challenging. But you have never gave up and you have accomplished a huge success so far. This is not the end. We have to learn a lot. We have just learned the foundational level understanding on data science and machine learning topics, and we have understood how they work and how to implement data science and machine learning skills. Now we have to learn everything in and out about those. But however, if you learn the data science and machine learning basics, the traditional machine learning, then what is next? What exactly you are going to learn in the future? That's what we have to understand, because the technology is advancing so fast. So the AI and data science as well. Data science and machine learning are heading towards the next stage of the success. So we have to be at the same level. That is why we should never stop learning the next advanced topic, as always we should do to be successful in data science, artificial intelligence, and machine learning. The next topics that definitely we'll be covering in this whole video tutorial series is going to be deep learning, computer vision, and image recognition, and so on, including natural language processing. The advanced level of natural language processing is going to be the large language model and generative AI. Generative AI or Gen AI is in high boom. So something, this skill is something that you definitely want to master, definitely want to learn. And you want to showcase your skill, your enthusiasm on the data science and machine learning. That is why these are the next stage of after you complete the data science and machine learning basic tutorials, basic understanding, including classification and regression machine learning model. And if you understand the basics, the foundational level, then it gets easy for you to dive into the advanced topic of data science, machine learning, such as deep learning, natural language processing, large language model, generative AI, and etc. So that being said, what exactly you can expect in my next series of the tutorials? So they are gonna be the mathematical intuition behind each individual models that I have explained in my this video that we have just finished. So we will be covering each and every single thing, the mathematical backstage of each individual models. So there will not be a single thing that you do not know about the machine learning models. Now, hands-on case studies with the real world data set. That being said, after we understand the mathematical intuition on the same video, we will try to implement that machine learning model, one specific machine learning model, in one real world data set. Mostly those data set are gonna be from the open source available data. For example, we can say city bike data, we can say iris set data set, California house price prediction, and so on. They will be very relevant to your learning on the real world business scenario. We will try to pick the best data set possible for each case study. So do not miss those videos. The next is going to be step by step model implementation and deployment. During this hands on case studies, we will be writing each line of code one by one in the video, and we will deploy them into the web applications so that you can showcase your skills by letting others use your app in those web applications. Now also will build the complex web applications where business users will be successful using your applications and making the business decisions. That's going to be our future stages on our tutorials. Please stay tuned and watch those each individual videos and get the best out of it, because this the time you are investing is a lot more valuable than what you can think. That is why I would highly advise to get the best out of these videos, best out of the available resource, and make yourself expert into this very high demand skill of the century. So best of luck with your future endeavors, and please stay tuned in my YouTube channel, and let's move forward and let's be successful here in the world of data science and machine learning. So welcome to my YouTube channel again, and thank you for watching so far. Let's get to the next step and let's keep learning and be smarter into the world of data science and AI. Thank you for watching.